Students, welcome to lecture number 19. This is the penultimate lecture of my portion. In this lecture, we are going to discuss more aspect of model evaluation. As you know, model evaluation also requires to understand errors and aspects of how to know that model is functioning properly or not. So, we are going to discuss these aspects also. But finally, we are also going to discuss a bit of things which I told you in the last lecture, that is data preprocessing. So, we will start with that and then move on to the model evaluation more further. So, as you know, in model evaluation we have several aspects. First one is obviously data, and that is one we start with it. So, you are going to start with your data from where from you have collected the data, source of data, and you need to check the authenticity and accuracy of the data. So, once you are sure about it, you can process or preprocess the data, and finally, you can do lot of processing. So, let us talk about that. So, in this lecture, we are going to not only finish the third portion, that is machine learning models and applications, and I am going to start the data repositories and featureizations. Okay. So, in that portion we have data in material informatics, you can see here, as well as some mapping of materials. So, in the subsequent lecture, that is the 20th lecture, I am going to talk about mapping materials. So, finally, we are going to stop there, and Professor Pratik will start from periodic table, elemental descriptions, descriptors, and other aspects of featureizations from lecture number 21. Therefore, model selection is very important, as you have understood, for a particular problem, and the selection of model depends not only on the data, but also on the type of problem you are handling, what kind of problems you are handling. So, many cases the problem which you are handling may require you to have some scientific understanding, in the sense if we know the background of the problem, then we can actually bring in the physics of the problem and handle it in a very nice way. So, that is how the model selection is done, but logically speaking, models selected based on the problem. So, like if you are handling a classification problem, then you need to select any one of these classification models I discussed about it, or if you require to do something like regression analysis, you are going to decide which kind of regression models you are going to use it, or if you are doing unsupervised learning, then clustering, there are different kind of clustering models I discussed about it. So, that is another way of looking at how you can select the models, but fundamentally speaking, model selection depends upon the problem. So, I discussed about the problem scooping in the last lecture. That is why actually problems are to be initially understood. So, if you understood the problem, then part of the use of model or the selection of model is much easier. So, let us now talk about data, right, because data informatics or material informatics requires you to handle data, and so initially we start with the data. So, data has different kinds of processing. First, I think is I discussed about data visualization. We always convert the data, large size of data suppose handling, into complex data sets into visual representations such as graphics, graphs, maps, charts, or sometimes various kinds of diagrams. Why do you do that? This enables us to handle large size of data or make a sense of the behavior of large amount of data very quickly and easily. Not only that, you can also understand or identify rather the trends, relationships, sometimes outliers or any other confidential informations, and can even draw some meaningful conclusions before you may apply the modeling. So, therefore, data visualization is very important. Initially, everyone resort to data visualization just to see whether kind of relationship which you are trying to understand between the different sets of data, is there a possibility of such a kind of relationship existing or not. And in order to do that, sometime we will find there are some outliers which are not going to fit in the way or scheme of thoughts which you have. So, you have to remove those outliers, that is also possible. So, data visualization has 5 different aspects. You can identify the trends and patterns, which is the primary goal. Quickly it will allow you to identify the patterns, trends, and understand if there are any outliers or not. It can also allow you to understand again insights. Okay. What is that? By making data more accessible and understandable, you can it can help us organizations nice way, so that we can understand how the decisions can be made. Okay. That is what. So, this organization of data is very critical when you are trying to develop a model. Third thing is the identification of the areas of improvements. Okay. So, data visualization tools enables users to uncover relationships between different sets of data. Many cases it allows you to understand their matrices and key performance indices. Okay. That is the way you can identify the areas of improvement. Obviously, machine learning reduces cost, that is we will know, because we do not want to use experiments to find the correlation among the different variables. Rather, we would like to visualize the data tools, we visualize the data in such a way that you can reduce cost of doing the modeling, simplifying the complex analysis, eliminating the unnecessary data processing cost, all these aspects. Lastly, it can allow us to in-depth understanding also. These tools can make it possible to create interactive visuals. Okay, many cases you can do that, interactive visuals that allows users to explore the data in a depth, but this requires you to model further. So, interactive visuals are not easy to do. Okay. So, in a nutshell, this is what data visualization does. So, you have different free data visualization tools available. This is taken from Greeks org, but you can have Google Charts. You can easily see it in once you log in and to Google. You can use Microsoft Power BI, Joe Analysis, Kibana, Plotty, Charts.js, Fusion Charts, Data Wrapper, Microsoft Excel, and also Tableau. Okay, Tableau is very famous, but let me tell you. So, therefore, these free tools you can use at your end. You can just use it, visualize the data, try to understand all those things I just told you. These are some of the maps or plots I have shown you for different kinds of data visualization. Okay. Like here, this one you see, this is simply telling you how the scatter plots, and you can find out some kind of a correlation. You can have even pie charts, you can have also bubble charts, you can also have parachute charts, and even you can have bar plots. There is a bar plots you can see here. So, even you can generate maps or different other kinds of plots possible. So, that are the part of parcel of the data visualization, which I will not discuss in detail, but this is all we learned in the process of doing science and engineering. So, let us talk about a little bit more of data preprocessing. So, data can be 2 types, obviously numerical or categorical. In addition, it can be static or dynamic, like temporal data, right. You are simply handling a video, my own video. So, it is a temporal data, right. As the video moves on, you are collecting data as a function of time. So, then there are other kinds of data like distributed data. You can have text, you can have metadata or images, audio, video data, everything. So, numerical data can be either discrete or continuous, and continuous data can have intervals, or it can be having a ratio in terms of. Discrete data can be ordinal, periodic or nominal data. Categorical data are mostly coming from these coding schemes or like yes and no type data, right. So, there are different types of data. First of all, when you obtain data from different sources, it will have a lot of issues, like it may not be clean enough. Sometimes you need to reduce the data, sometimes you need to discretize also some information, or integrate different databases, transform them also. So, that is why you need to preprocess the data. So, the main problem is this, the quality of data. Most of the data in real world are very dirty, mostly in terms of incompleteness, they are noisy, they are even inconsistent. So, therefore, you need to take care of that. So, most aspect is the missing of different attributes values. Okay. You may have some things are missing, somebody has not put it together, there are many reasons for it. So, therefore, cleaning and transformation actually consists of majority of the work in data informatics. Let me tell you, almost 90% of your time will go into cleaning and transformation of the data, because if you have bad query data, every model will be giving you bad results, does not matter how powerful the model is. So, when you talk about quality, you talk about these aspects that you must remember. First of all, accuracy, very important, because everybody is looking at machine learning model to predict something, and you want to have a very high accuracy in the predictions. So, that will depend on what is the accuracy of a data. Then you have to take care of completeness, consistency, I already discussed about it. Sometimes you need to take care of also timeliness. Some data actually are updated every now and then. So, if they are not updated, you have a problem of timeliness. Then you have a problem of belief, value additions, interpretability, and most importantly nowadays you have a problem of accessibility. Many of the databases are not accessible to you. Then what do? You cannot actually handle it, right. So, in some many cases you have to pay money for that. So, in case of data cleaning, integration, transformation, reduction or discretization, these are the major tasks normally we do in data preprocessing. Let me tell you that in case of data cleaning, you have to fill the missing values, smoothen the noisy data, identify and remove the outliers, resolve the inconsistencies, and you also need to integrate different databases coming from different sources. There will be problems, right, because some data are represented in metric form, some data are in some data are in SI units. So, this problem will always exist. Some data are having different number of columns and rows, and then you have to have transformation like normalization, aggregation kind of things, reduction and discretization, everything is required. Okay. These are the aspects which you have to know very well. And so, these are the tasks we do, fill in the missing values, look at the outliers. So, let us not talk more about it. Missing data is always very bad, and so noisy data is something which you will find random errors and variation in the major variables, and there are many other problems also possible like duplicate things, inconsistency. So, you can handle this by using 3 methods. First is called binning method, second is called cluster, and third obviously combined computer human inspection. So, what is the binning method? First you sort the data and partition into different bins, just like you have different bins when you collect garbage. Same thing, you can have different bins to sort the data. They can be equi-depth bins or non-equi-depth bins, and then once you have bin the data, you can actually smoothen the bin, smoothen the data by bin means or bin median or bin boundaries, all kinds of things you can use. That is, this is there in many of these visualization things also. You can also use clustering techniques I talked to you, right, to detect and remove the outliers. So, you can plot the data, make different clusters, and if you find some data outliers, simply remove them. And obviously, you can use your own intelligence along with computers and to detect the suspicious values and deal with possible outliers. So, this is the example, you can look at it, I will not go into details of that. So, you can partition equi-depth bins, smoothen the data using either bin means or by bin boundaries, this is possible. So, you can always remove the outliers by clustering, you can also do curve fitting, you can also do hypothesis testing also possible. And integration I talked about it. So, integration from different sources. So, you can use schema integrations, integrate a metadata from different sources, and like you can see that this is A customer ID data versus B dot customer ID some data. So, sometimes it will also need to detect and resolve the data value conflicts. So, some real world identity attribute values from different sources can be different, like different units, different scales, different values. So, you have to take care of that, otherwise you may not be able to integrate it properly, and obviously you need to remove the redundant data and duplicates. Okay. So, how do you do transformation of data? You have to smoothen the data, right, remove the noisy data, normalize it. You can always even feature construction possible from the data. Many cases you can sum it, aggregate it, or you can actually do generalization like hierarchical climbing kinds of things. So, hierarchical clustering you have done, you can generalize the data also as possible. So, there are many ways of normalizations, let us not go into details of that, mix, min, max, z-score normalization, or you can do normalization by decimal scaling. We all do these things in your class 12 standard or first year, BSc, MSc, or even in BTech level, right. So, sometimes data are too large, reduce the data dimensions, and there are many ways. One is called dimensional reductions. So, suppose you have a 10 dimensional data, 10 dimensional 10 attributes are there. If you want to develop a model connected with 10 attributes, this will be very complex. So, first you remove some of these attributes, unimportant attributes. That is the way of reducing the dimension of the data, right. So, you can use aggregation or clustering or sampling for that purpose also. Data reduction is very important when you want to know which are the primary variables affecting your output. So, feature selections, heuristic methods is also used. You can have minimum set of attributes to be used, that may be sufficient for data mining task, or you can use heuristic task also to do that. So, I can use the histogram plots to know which is the best way of looking at which are the variables or features which has highest impact. So, this gives you buckets, right, and you can see that this one bucket here, one bucket there, right, one bucket there, then one bucket there, right. You can see that, you can do that actually, that is possible. Clustering is another way, I talked about it. You can do sampling, choose representative subset of the data, that is called sampling. Okay, sampling is very important in many aspects of machine learning, and you can use random sampling, or you may not use random sampling. Sometimes random sampling can give you poor performance. So, that is why you have to better use stratified sampling, approximate the percentage of each class in overall database, and then you subpopulate this. That is possible, that is called stratified. Stratified means state stratified. Okay. So, this is what is, you can see that this is called raw data, and this is called stratified sampling. Stratified sampling means we can use, this is one, this is another one, right. You can see that. Similarly, this is one, this is one, right. You can do that. These are the stratification of data. Then you can do discretizations, you can do nominal discretizations, you can be, values can be unordered states, or you can do ordinal, you can do continuous real numbers. Some techniques like binning method is widely used for discretizations. You can use entropy based methods, and that is very common, like you can use even number of values for a given continuous attributes can be by dividing simply the range of attributes in the intervals. It is all very simple thing, I do not want to talk about it. Binning is what is shown. You can use EQ width binning or EQ frequency binning for different kinds of data. So, EQ width means you can see that there are 3 bins, width keeps same. Okay. EQ frequency means there are 3 bins, the frequency is remaining same. That depends on how the data are distributed. Okay. So, best is used to entropy based methods that allows to calculate entropy of the distribution, and if the set is relatively poor, entropy will be very small. Okay. Remember, we go back to discussion on the decision tree where we talked about it entropy quite a lot. So, I leave this slides for you to do more of these things. Okay. So, now I will start discussing on the model evaluation a little bit. So, what are the ways you can evaluate model? Let me go back to the board and discuss with you little more further. Okay. So, as you know, evaluating machine learning model is very critical. So, there are 5 aspects in evaluation, I will talk about it. First aspect is called train and test split. What is that? This is nothing but if you have a data, then you have to train the model first, right, you understand, right. Simply like the way you get trained in a childhood to do some kinds of things, the model needs to be get trained. So, when the model is trained, you should know that model has got trained properly, right. So, you do some test on the model. So, that is why you have to do a 10 test split. So, database data sets are split into either 80-20 or 70-30 kind of things. That means 80% data will be used to train the model, 70%, 30%, so 20% data will be for test the model. Same things for the 70-30. This is the first thing you do. Okay, when you are evaluating a model. So, you have to simply test and train and test the model. What is the second thing you do? Second thing is very important, what is called a validation set. This is sometime optional, but it is recommended for you to do that. Okay. What is validation sets? So, in many cases you need to do some kind of a tuning of the model, like hyperparameter parameter tuning, or some kind of times you have to do some like ANN models, you have to do a back propagation. So, for that you need a validation set. So, you can always keep a separate set of data for validation purpose. This prevents you to overfitting to the test sets during the tuning process. Okay. So, typical splitting may be 60% training, 60% training, 20% your testing, and 20% validation and 20% training. Okay. So, we will talk about more about validation now. So, this is the second step, that means you keep a separate set of data validation. Okay. This is required for back propagation, or you require is for hyperparameter tuning of the model. You understand that. Third thing is basically known as a cross correlation, sorry, cross validation, not correlation. You must be thinking what the difference of these two, validation set. Here we are keeping certain amount of data for validation only. So, what is cross validation? Okay, let me discuss in detail about the cross validation, and that is something very important for you to know what is cross validation. Here we do not use the whole data sets for training, but some part is kept for testing. Okay. In the cross validation, main aspect is called k means or k fold cross validation. You understand from the word validation that you validate something, right. So, once you train here 60% data, the model is trained, then you validate the training process, the training was done properly or not, that is what you do always, right, and then subsequently you test it. So, what is then k means k cross validation? So, original data sets is divided into k sets, k can be any number. So, you have original data sets, you divide into k sets. Then what you do? These subsets, this k subsets basically, whether write k sets, whether write k subsets. So, you divide the data into k subsets. These k subsets are called fold, k fold. So, that means each subset is called a fold, right. That is why the name came k fold cross validation. Then what you do in this case, one fold. So, one fold is used, but the first fold is used for testing, and remaining k minus 1 fold is used for training, right. Suppose you have 1000 data, you divide this data into 10 sets, right. So, their k stands for 10, and then first set, that is 100 data used for testing and 900 data is used for training. That is what is called k fold. Okay. So, this is seen that this technique generalizes the model as well as reduce the error rate. That is why it is used. You generalize the model and reduce the error rate quite a lot. So, compared to validation set, cross validation is better, let me tell you. In cross validation, you are dividing the data sets into different sets, and then you are doing this work. So, you also have to remember there is something called a hold rate. So, the data sets can be divided into training and test data sets, and okay. So, this hold rate is basically kind of a how much you can keep it on hold. So, that means suppose you are here you are seeing 20% is keeping on hold for testing, here you are keeping 40% almost for the testing, right, because this 20% also used for validation. So, that is what is called hold. Okay. So, depending on amount of data, you can keep it more on hold for testing. So, am I clear? So, this is the very important aspects you should have to understand, very important aspects. So, this training followed by validation or cross validation very important. Then fourth aspect is what is known as the evaluation matrices. After you have done the model, you have to evaluate the model. So, evaluation matrices, different evaluation matrices are used, let me tell you. what are the different evaluation matrices we can use. So, let me first tell you that the first is called obviously accuracy. Okay. How do you define accuracy? Okay. Then you call, these are basically, there are two types here. One is for classification algorithm and second one is called regression type algorithm. Regression also, and you can also use for your neural network. So, in classification algorithm you can use as accuracy, precision, recall, you must have heard about it. We will discuss about these aspects, detail, recall, F1 score, and also you have something known as a confusion matrix. Okay. They are all coming from there. Then a regression, you will use various kinds of things, what is called mean absolute error, mean square error, root mean square error. Okay. You can also use R square, and then you can also use other aspects, right. So, we will talk about that. So, this is the part 4. Part 5 is what? You also need to know a little bit about baseline comparison. Okay, what is that? This, you can always compare the model performance with some other baseline models. Let us say you are using several models and you know that one particular baseline model performs very well from your experience. So, you can compare the model's performance with that model, your model performance with that model, that is called baseline correction. They can also use what is known as addressing biases, always there will be always some bias, and fairness. So, these are all required when you develop a model. So, when you start monitoring and deploying a model, you need to do some other sets of things which we will not discuss in this class today. So, you see these are all very important things which you need to discuss. So, I have already talked about 1, 2, 3. So, we will discuss more in the next part of the lecture about what are the different evaluation matrices and what we can use it. So, we will come back to the next part of the lecture and discuss about that. So, we will the next part of the lecture we will discuss about the different evaluation matrices, that is the point 4, both classification and regression, and in detailed manner I will discuss with you.